Hey everybody, this video is on ratios and rates. Both of these topics, ratios and rates, relate quantities by division, their relative size by division. They're also related to our friend the fraction with a few distinct differences. Fractions always have the whole in the bottom, and they're written with the fraction bar, obviously. Ratios can be written several ways. Say, for example, 7 to 8. They could be written 7 to 8 with these two dots like a colon, or 7 per 8, just like in a fraction. However, there's a difference. In a fraction, the whole is always in the bottom. In the ratio, you don't know if the 8 is the whole, or if it might just be another quantity. It could be that there were 7 stars per 8 circles, and that would be a ratio of stars to circles would be 7 to 8. In total, there are 15. If you're talking about a fraction, the fraction of the whole will be 7 stars out of 15 total. The fraction that would be circles would be 8 out of 15. So fraction has the total in the denominator. Ratios may or may not. These are a ratio. It's 7 to total, 8 to total. Another thing that ratios have in common with fractions is that they should be expressed in a simplified form. So just like with fractions, you'll be looking for the common factor. In this case, 3. 2 times 3 is 6. 2 times 4 is 8. The common factor is 2. Therefore, 6 to 8 would be best expressed 3 to 4, just like it is in fractions. And another often unnoticed difference in these as well is the notion of units. Ratios involve the same units. So it could be that, in one place, in one oven, you let something bake for 5 minutes, but if you're working with a different oven, you might bake it for 6 minutes. These units are the same, and if you're talking about oven A to oven B, then the ratio would be 5 to 6, or 5 to 6, or 5 to 6. All the units are the same. So it's important to notice that when we're talking about ratios, the units have to be the same. Both of these are units of time, but they need to be converted to make sure that you get the right ratio. Half an hour, as most of us know, is 30 minutes. 5 minutes, of course, is 5 minutes. Now we've got minutes and minutes. It's a ratio. These units are the same. However, if you look at that, can you see what else has to happen? Hopefully you see that this is 5 times 1. You see that this is 5 times 6. That's what 30 is. 5's cancel. 5 goes into 30 6 times. And 5 goes into 5 1 time. So your answer is 1 to 6. That's going to be the ratio minutes to minutes. 1 minute to 6 minutes. When talking about rates, rates are very similar to ratios except for one important difference. Rates involve the blending of 2 units. In this case, miles and hours. You might have traveled in a car 85 miles in 2 hours. So 85 miles per 2 hours becomes a rate. It is a rate of speed. It's not in miles, it's not in hours, it's a rate made up of the 2 blended through division. This lends itself to a very common thing that you've been associated with many times, the unit rate. How much is this per song? How much is gas per gallon? What is your speed in miles per hour? So in this case, the unit rate, 85 miles per hour. The 85 is divided by the 2. And you get 42.5 miles per 1 hour. Often written as 42.5 miles per hour. Per always means divide. The miles are divided by the hours, not the hours divided by the miles. 42.5 miles per 1 hour. That's why it's a unit rate. because it's per 1. Anytime you have two different units, could be a little snail crawling along at 3 centimeters for every 30 seconds. If it's going 3 centimeters for 30 seconds, if you wanted to get the unit rate, you would divide 3 by 30, which would be 1/10 of a cm per second. That's the unit rate. For each 1 second, this snail travels 1/10 of a centimeter. 1 millimeter per second. Rather slow even for a snail. Okay, so for your first little homework question here, if you kindly express the relationship between stars, quantities of stars, and quantities of boxes using a ratio, and of course always in fully simplified form. Secondly, can you express the relationship between these quantities, 12 inches per 2 feet, as a ratio? Remember, you might want to review your notes from earlier in this video about what exactly a ratio consists of, so that you can get 100% correct answers. Okay, so for the last bit, if you could kindly write out, these are rates because they have mixed units. Could you write 700 meters per 120 seconds? Write that out in the proper form. Same deal, this one, 700 meters per 2 minutes. You might notice these actually are the same rate, but just different units. Same speed, I should say, in real life, but they just have different units, so you're going to get a different answer. And lastly, could you provide the unit rate for the top one and the unit rate for the second one? Some of them might be the same, some of them might be different.